So on page 149, hey. On page 149, you can see the 3 pictures we just made with our Twizzlers. If our lines intersect, which is going to happen a majority of the time, okay? When our lines intersect, we have one solution, x comma y, okay? Now, if our 2 lines are parallel, they never intersect, so there's no solution. If our lines overlap and they're the exact same line, they share an infinite number of points, so we have infinitely many solutions. What's up?
How are we supposed to tell if it's infinitely many solutions? Because if the lines are overlapping and we can only see one line, how can we tell?
Well, if it's a system of equations and you only see one line, you know that you have 2 overlapping, okay? But what I really care about is how we can tell algebraically, okay? So, turn the page. Okay. We are not going to solve number 1, but we know number 1's answer without having to graph it. Those are both in y equals mx plus b form. What's the slope on both of them?
3x.
Is the y-intercept the same?
No.
No. So we know right here that these are parallel lines. So there would be no solution. Now, unfortunately, that's not how we're going to solve these, okay? I just wanted to talk about that because, we could see that, okay? But let's go to something.
So in order for them to be parallel, they would need to have the same slope and the same, in order for them to be perpendicular, so for infinitely, they would need to have the same setup, so 3x plus 4 and then 3x plus 4.
Right. But we're not always going to see it like that. Look at number 3, okay? Is this one ready for us to use elimination? Yeah. Okay, so let's see what happens when we use elimination. What's 2x plus negative 2x? 0. What's negative 3y plus 3y? 0. And what's 10 plus negative 10?
0.
Okay, so I have a question. How often does 0 equal 0? All the time. This is a true statement. All the time. So, our answer is infinite solutions. You can do that too. Or the infinite sign.
I like how people say infinity, but some people call it infinity. Infinity is when you add the line, not any.
Okay. Now, what I'm going to do is I'm going to go, hopefully, to Desmos. Nope. Where's my math? Okay. And I'm going to type this into Desmos. So the first one was 2x minus 3y equals 10. So here's that line. Okay? Then I'm going to graph negative 2x. Aww. There. Plus 3y equals negative 10. Okay, so here is line number 1. Here's line number 2. They are the same line. We share an infinite number of coordinates. Okay. All right, now let's go to this number 4. Oh, this is awfully nice of them to already have our x's as opposites. We're ready for elimination, aren't we? Yes. Okay. X plus negative x. 3y plus negative 3y.
0.
Oh, but what about 6 plus 3?
9.
How often does 0 equal 9?
Never.
0 equals 9. That is not a true statement. Ever. So here is a case where we have no solution.
So basically, if we're adding both numbers, it have to be a positive, and if one is negative, we subtract.
I am not following.
So we added here. So basically, if these are if this was a negative 6, would it be 6 minus 3? Because it would be a little tricky to tell if we're adding, whether we add or subtract when we're doing deletion.
So with elimination, we're always going to add.
Okay.
Okay, so here is line number 1, and here is line number 2. Notice they're parallel. Hey, Camden and Connor, can you maybe pay attention up here and stop screwing around? Thank you. We have 2 lines that are parallel. They're never going to intersect, which is why we got no solution. 0 doesn't equal 9. No. Okay. All right, now let's look at number 6. For number 6. Oh, look, we're already ready for elimination, aren't we?
Yes.
Okay. So I get 5x plus 0y equals 5. How many solutions are we going to get?
1.
We're going to get 1 solution. We're going to get x equals 1, which is totally cool. Okay. Then I'm going to throw it back into the second one. 3x plus 5y equals 8. What did you say, Aaliyah? Did you have a question, Aaliyah? Okay. Maybe it wasn't your voice that I heard. Did somebody have a question? Okay, so let's recap this here. Essentially, if you get, kind of like with when we were solving just one equation, if you get 2 numbers, in this case it's 0 equals 0, but maybe you use substitution and you get 5 equals 5, 17 equals 17. If your x's and y's, poof, cancel out, and you get a number equals a number, if they're the same number, we have infinite solutions. If they're not the same number, no solution. How often is this true? All the time. How often is this true? Never. If your x's and y's don't both cancel out, it's just like we did all last week, we're going to get a solution. Okay? Now, normally, I think I would have you try a couple and then we'd talk about them. But I know that the break is coming up, and the more homework I can throw at you, I think, in class, the better you're going to feel. But I don't remember. Who has the gold sheet? in front of them. The gold sheet that says all of our homework assignments. Oh, yeah. 5.4, 3 through 8 all, and 9 to 21 odd. All right, so on here, you have 3 through 8 all, and 9 to 21 odd. In 3 through 8, you're matching which ones are which. 9 through 21 odd, you're finding me the solution.